Okay, I'll I'll be talking about the Docker project right now, and then the first thing we have to do is to clone our repository. That is after we have created our repository. So we're going to clone it. So I'm going to my repo now. So our repo actually. Okay. We will go to our repo. After we've created the project, you will now come here and copy the link. You click this code here, then you copy the HTTPS, the hypertext transfer protocol. If you want to use SSH, you can use SSH, but we are not using SSH now to log in into it. We are going to use the HTTPS. So we'll copy this one and git clone. That's a clone using the web URL. So we can git clone and clone that web URL. Then after we've done copy that, we will now go to our Visual Studio Code, right? Okay, wide. Then open our terminal. Then I think I'm putting it from PowerShell to cloud git bash, right? So now I want to clone it. Where did I want to clone it? I want to clone it on my desktop, right? So I will change directory to desktop. Okay, it's in my desktop now. Alright, you can clone it here, or you can decide to clone it in another place. So me, I want to clone it in another place. So I'm listing. I have a folder called TechRush Cloud Computing. This is where all my TechRush projects are. So I will just copy it, right? And I will now change my directory, CD, and then paste it. So I've changed my directory here. So this is where I want to clone it, right? So I'll now git clone. Then I've already copied this one. So let me copy it again. Let me copy the URL again. Then paste it here. And then now cloning into Docker project. So I've already cloned it now. So it's already in this thing. If I list it now, the name Docker project is there. Look at it, Docker project. Then you change directory to Docker project. Docker project. Now you see that now main is now showing that we are in a Docker project. And then you list, you see that all the Docker files that is in our GitHub are there. Then all you need to do is to now code into it to open it in your VS Code workspace. So when you code, you see that another listeners come up here, and look at them. Docker projects, everything that under the Docker project is here. So I think I'll remove this other one now, since I have this one now. So I'll open my terminal here again. So this now I have my terminal under my Docker project, right? So I'll change it to git bash. You see that automatically it's going to be under the Docker project itself. Yeah, look at it. TechRush Cloud Computing Docker projects main. So that is down with that stuff. That is how to actually clone your repository that you've created, and be using it in your terminal stuff of the thing, right? So then the next thing is for us to talk about Docker files of the back end. This is a back end folder, the front end folder. Then this is the GitHub Workflow, right? So and then this is the Docker Compose. So first of all, let's talk about the back end folder. I've talked about it day before yesterday, but we'll be talking about it today again. Alright, I said there are two stages that we did, but before we created the Docker folder, what did I do? I said I'm going to do Docker initialize, that Docker init. When you use this Docker init, they are going to ask you series of questions. Yeah, but I don't want us to Okay, let's see how we can do that. Docker init. Now, you see the following Dockerfile already exists in this directory. Do you want to overwrite them? So now look at it. You say this utility will walk you through creating the following files with sensible default for your project: docker ignore, docker file, docker-compose, and also we will even create a readme for Docker. All right. Okay, let me override them because after I do all this thing, I'm going to delete what was there. So now look at the series of questions. I've already said yes, I want to override them. Now I say, what application platform does your project use? Automatically, it has already read what is in this backend folder, and it knows that it's Java that is there. So you knowing that it's Java that you use, you are going to choose Java. So now it's under here is all other. So you come up, see now you can navigate through. You can navigate through with your arrow on your keyboard. So I choose Java and press enter. Then what is the next question? You see what's the relative directory that is with a leading for your app current directory, right? You click OK, is your current directory. What version of Java do you use? What version do you use in your in your encoding? I use version 17, so I'll use the press. And I say, what port does your server listen to? What port does my server listen to? My Java, I told you that by default is 8080, so I'll put 8080, and then you see that now inside it, some things have already changed inside this backend file. It has only the Docker and the Docker ignore before, but now, okay, your application will be about, okay, before that, start your application by running docker-compose build and then localhost and whatsoever. So looking at it, you could see that now how in my back end here, right, Dockerfile is here already. See, everything is here, it has been done. Docker ignore is here, docker readme is here. Then the docker compose we clone from our repository, he rewrites it again. Look at it, he rewrites the docker compose now. That before it has two services, now it's having only one service, which is only the back-end services. You could see it now, right? So that is that. And then, so let me just explain what is in this Docker file here. Yeah, now this is the build stage, right? But you can decide to write all this code all by yourself. But no, if you don't understand the structure, you will not be able to come up with all this. So instead, you use the Docker initialize. It helps you to do all this stuff. So now look at the build stage. Now we are going to build the back end files before we now run it. So it has build stage and the run stage. So from build stage, the first thing we are going to do, we are going to, from our Docker Hub, I've said it before. If you go to dockerhub.com, you are going to and search for there are series of Linux servers or Linux computers that are already there. Docker have already made it available for us to import and use to containerize and dockerize our applications. All right. So from your Docker Hub, you import Eclipse Temurin. Eclipse Temurin is a Linux server, right, that has Maven of version 3.96 and also Java of version 17. So since we told it that I use version 17 for my that is for my coding of my back end, okay, automatically it will look for since we are now have initialized it will look for a Linux server that contains Java tools and has Maven, and then its version is 17, right? Then what is as builder mean? As builder mean that we are now naming all these things, right, as builder, because we are going to make reference to it later. So rather than writing from, we'll not write all these things that are here, we'll write everything again. No, we name them as builder. So look at all these things here as a computer, a Linux computer, a Linux server that you want to build from, right? So Now you import it from, and then you name it as builder. Then the next thing is your working directory. Work that means working directory. So now in that your computer, which is this one, Maven, in that your computer, you are creating a working directory called app. You are creating a working directory called app. So this is a build stage. You are creating a working directory called app, and then the next thing, you are copying your pom.xml file to this working directory. This dot at the after the space is pointing to your current working directory, which is your what? App. So which means that this your pom.xml file is your local repository, is in your file here locally on your local machine. Look at it here. It will copy this thing and put it in this your working directory inside this your computer. That's what it's trying to say. Then same thing, it is going to copy your src folder that is in your backend here. Look at it. Your src folder that is in your backend, your local machine. It's going to copy it, and it's going to create another src folder in that your Linux computer that you imported. Is going to create it inside the app. So you see that you put ./src, which means that dot is your working directory app, and then you will create another folder called src, and then copy our local machine src into it. You see it now. Then the next thing is now to run your Maven package. So what does this one do? It runs or builds your Maven package, and then in batch mode, that is tac b means batch mode. And then when you say clean, it now cleans your old building. Then let's say for example you build before in your Docker engine or your Docker desktop. So this clean here will now clean your old build and then package it for you again. Right, it will package it for you again. And then what does this one mean? It skips any test to save time, your building time. So rather than testing while it is building, it skips it to save time. So that is what this build stage is, right? That is what this build stage is. Then the next one is to run the run stage. That is this time around to now run it, to be showing on your Docker engine exactly, to now be running it. So now this time around, you're not going to choose a lightweight Linux server from your Docker hub, which is from Eclipse Temurin :17 JDK. That is the version of your Eclipse Temurin, that is your server that you are importing from Docker hub, is 17. So this one has also Java 17 inside. So from there you are importing all these things, and then you are now creating in this computer right here, in this computer that you imported from Docker hub, you are now creating app folder. You are creating an app folder, that is working directory. You are creating an app directory, and then this time around you are copying. Now remember we said that we named this first Linux computer, we name it as a builder, right? Now we are now copying what we built inside this computer. We are copying it. Now let's see, tac from builder app.target. This builder, what it's built is now located in app, that is working directory, in this working directory app target, right? Then all of Java files, all the Java files it has built in this computer in the working directory of app, right, in target, is going to copy every Java files. You remember that in batch scripting, asterisk means a wildcard. It copies all. So it copies all the Java files from this builder, from this computer named builder, to what? app.jar in this computer. App.jar in this computer. It's going to copy everything from this to this computer called app.jar. Then the next thing for you to do is now expose the port. So this time around, we're not telling that, computer, this thing, whenever a person wants to come and communicate with this my back end, is going to communicate through what? 8080. You remember 8080 is an HTTP request, hypertext transfer protocol request whereby a user communicates through the browser to your website using what? Port 8080. So after expose this my computer to 8080 or expose this my backend website to 8080 so that whenever someone comes and use localhost colon 8080 is able to access this my website that I created. Are you getting it? Right? So it's going to access it. Then entry point, or you can also call it CMD or CMD. I can decide to use CMD. No, see, I can decide to use CMD, that is command or entry point, right? But in this case, oh sorry, Control Z. In this case, I use the entry point, and also I can decide to remove all these things. You see now, I can decide to remove all these colons, all these comma and this thing. You see that it's still there. So which means that you say that when you writing this command after you have built and run this thing, if you write java space .jar space app.jar, run it. So this is a trigger command to actually run. That if I type it after I've built this thing, if I now type java tag jar tag space app.jar and then run, it's going to run only the back end file. So that's why containerization is important, right? Containerization is important. Let's say, for example, you just want to run only the back end file, you just use this, right? So that is that. So that is that with this Docker file of the back end, right? Then let's now look at the Docker file of the front end. Remember, I said it also that if you do not understand how to write your Docker file of your application, you use the Docker initialize. So also in this place, I used the Docker initialize, and it created this stuff. Okay, like I've said, you use the Docker initialize to actually do your Docker file, but the thing is that it's not going to do only your Docker file. It's going to do your Docker file, docker ignore file, your Docker readme, and then your docker-compose.yml file for you. All right, so that's what you use. So no need to do docker init again. So now let me just explain the Docker file for the front end. You see, for the front end right now, you are now importing. Remember the same thing. You are importing a computer from both from your Docker hub, right? You're importing a computer, which is what? Nginx. What is Nginx? Nginx is a web server that helps you to host your website, your HTML, CSS, and also JavaScript file on it. So it's a fast website server for hosting website. So this time around, we are what? Importing a lightweight. What does this Alpine means? Alpine means at least a light version of Linux of and that has Nginx installed in it. We are importing a light version of Linux that has Nginx installed in it, right? So we are importing it, right? We are importing that computer, and then we are copying. What are we copying? The current directory of what is the current directory now? This front end. We are copying it. We are copying it into what? This user share Nginx HTML. This user share Nginx HTML is the default folder for Nginx. This is where Nginx used to come and check the files that you have. And okay, you have HTML, CSS, and JavaScript here. Okay, come, you guys should come. Let me host you. All those kind of stuff. So this is the file. So we are copying our current folders, our current files inside. That is the index HTML, script.js, and style.css. We are copying everything into this folder inside our computer, our lightweight version. And then the last thing, we are exposing it to port 8080. Remember, this port 8080 is a default web port whereby a default web a front end port whereby a user will come and interact with your front end website, your front end. Remember, 8080 for Java is your back end. All right, your back end is a default port for your back end. Right, so this one now is a default port for your front end folder. So this, I've already explained the Docker for both the back end and the front end. So now I would be explaining the docker-compose.yml file. Right. Okay, now for the docker-compose.yml file, remember docker-compose.yml file is like a product manager that helps you to run multiple services all together. It helps you to run multiple services all together. Let's say, assuming we have also a database, it will also run the database for you too in this place, right? So this time around, the purpose of this one is just to run only the front end and the back end service, right? So now what is the first thing to do is to you tag your services. So what are the services it has? It has what the back end service here. You see that the back end service has all these things inside, and then it has the front end service here. It has the front end service here and all the things inside. So let me explain the back end service. So for the back end service, now the image you are building, right? This is the image you are building, but at first you want to create a GitHub, a Docker repository. So instead you go to your Docker repository. Now, okay, this is my Docker repository. Let me just come here now. Repositories. Now look at this. This is my repository, right? It has 4 images. These are images, right? Look at it, images. These are images. So you can create a repository here, all right, and then name it. Now let's say Java front end, all those kind of stuff, and then describe what does it mean and every other thing. Then in your local repository, what are you going to do? You are going to do docker tag your local name, and then the tag name, latest version, right? And then docker push. You see it now. So the name and then the tag name, the name of your repository and then the tag name, right? That is after you have created all this stuff, right? But let's not dwell in this one for now. No, not this place. Let's just go back to what is here. Okay, so Dockerfile, right? Dockerfile. You can decide to now you've created your GitHub, your Docker repository as a Java Backend, and then automatically the tag given to it is latest, which means latest means is the version, the newest version. Latest version is the newest version actually, but to some used v1.0.0, some used v1.0.1, but it's recommended to use latest version. So that's why it's latest version here, right? So you've created your Docker repository. You come to your terminal, and then you do docker login. Then you log in. It says please enter to open your browser or submit your device code here, right? Okay, docker login, then tag username, then my username is Dockerfile, right? Let's see. Okay, it's still waiting for browser to authenticate. Let's open our browser. Look at it. That is actually working, rather than even using the Docker login username. It's already recognized my username as Dockerfile. So now it's just for us to open browser and authenticate. So there will be a Docker CLI code that will be given to us here, and then you will press confirm. Once you press confirm here, congratulations, you are all set. Now go back to your terminal. You see that login succeeded. So you have to wait here now. See, login succeeded. It has shown here. So which means that you have already logged in to your Docker. Then the next thing for you to do is to now build your Docker. Is to now build your Docker file using docker-compose.yml. When you build your Docker file using docker-compose.yml, as it has built already, right, you will now push this your image. You will now push it to your GitHub repository of your username, right? But after I talk about the docker-compose.yml file, we will now talk about how to push and every other thing, right? So this is your image, like I've said, that is in your Docker repository, right? For your back end, right? This is a nickname. This is your username. This is a nickname. This is your tag name. Or a nickname or your repository name. Then volumes. What does volume mean? Volume helps you to link your backend folder in your local repository to your computer folder. That is the computer that is hosting your Docker file, that is hosting your apps and every other your application, is linking them together. Why are you doing this one? Because in case you change anything in your code in your Java backend, let's say for example you change your student name to student names or whatsoever in your Java backend, for example, it is going to link it to your app source. Also, the app file, they don't change them. It's going to link it there. So that one will now accept it. That okay, you accept the changes that have been made in your local local repository here. It will accept the changes in that Linux computer there that we imported in our Docker file in backend. It's going to accept it. Then that is what the volume is. It helps you to link your local folders in your machine to your Dockerfile Linux folder or Linux machine. It's going to link them together. How do we know this app /src? If you check your Docker file, we have it here. Remember, see it, app, and then there is a source. Look at it here. So src, we are copying our folder from our local repository. The src of local repository, we are copying it to the machine's src. So this time around in your docker-compose.yml, what are we doing here now? We are linking our backend folder of our local repository to our Linux machine in the folders, right? We are linking it so that in case you make any changes, automatically we'll make changes there, right? Then build. What does this build mean? It means that it should build from where? Your back end, which means that if you run this docker-compose.yml file and then it's reached this build aspect, where am I building from? Right? It's not saying, okay, from your backend folder. What is in your backend folder? We have the source and every other thing that's needed to build your Java backend. So it's going to build from your backend folder. That's what it's trying to say here. Build from your backend folder. Right? Then container name is simply the nickname of your container, so that whenever you want to troubleshoot what's happening, whenever you want to show the logs of your backend, you can just write docker log, then log, and then the container name, Java backend, right? And then you now click enter to see what's happening in your Java backend. So then remember we talked about the volumes, that whatsoever changes is being made in your codes here is going to automatically link it or connect it to the Linux virtual machine, and then update all the code that have been changed here into this folder in that Linux machine. It's going to update everything, but it cannot work without this develop. Remember, that's why I say this volume aspect is not just for infrastructure engineers, it's also for developers. That is those people that you after you run your this thing on your Docker engine, and then you now check the way your back end is responding with your front end, you don't like it actually. You know, say, no, this thing is not working. You now come back to your Java backend code to come and check some things, and then you now change some things. Once you change some things, automatically it will link it to this app.src in your Linux, this thing that you have already hosted while it is running. But it's not going to do anything at all. No changes will be made there unless you put this develop this thing. This is for development, live development. And then what does this watch enable now come and do for you? This one now will now watch whatsoever is happening. So when this watch is here, what does it do? The action first is going to sync what the code is, the codes that you've changed in your back end. Is going to sync it with the app SRC in your Linux machine. Right, it's going to sync it there automatically. And then what is the path? The path, where is it syncing it from? That's what he's trying to see. He's syncing it from what? Back end SRT. That's, I told you that I say, and I don't like what the response I'm getting from my front end, from my back end through my front end, right? And then I come to my back end folder and change some code. So the path is syncing from my back end. That's why you see back end /src, my source. SRC means source, right? Source folder. Then where is it now targeting it to your what? App/src. Same thing in this your volume. Backend /src to your app/src. So it's watching what is happening in your code in your local machine, and then is now, once you change your code, it look at it, and then automatically it will not tell your virtual machine that after this thing has, they have already changed this stuff. Update it fast. So the next thing is now action. Update it fast means this action rebuild. So automatically, when you change something in this your back end, automatically it rebuilds. And when you go back to your web browser to see and then check the interaction of your back end, you see that it has already been updated. On which path? Your what? Back end pom.xml. What does this pom.xml do? This one is for developers, not actually for cloud engineers. It's for developers. What does this pom.xml do? Now in this your backend, your pom.xml has dependencies. What are the dependencies? Dependencies for your backend to build from. You know, so it has Spring framework, it has your version Java 17. You see now that it has the version of Java you want to use. Then also it has your Spring framework, it has your everything, every dependencies. It has all your dependencies you need to run from. So is this path is going to rebuild again. So whatsoever you change in this your the XML file is going to rebuild it there. In that, that's what it's going to rebuild. It's going to rebuild this your pom.xml file, your dependencies, and then everything that you've changed in this code will now automatically update. That is what the develop section does in your back end. That is what the develop section here does for your back end. It's going to sync what you change in your back end code, will sync it to what? Your front end code. Right, and then rebuild. Remember, this develop watch action and this volume works hand in hand. If you do this volume, if you write this volume and you do not write this watch enable, it's not going to work. It's not going to update until you write this one. So this one now brings about live update. So whatever you change your code, automatically it updates live while your app is still running. So these ones are for developers, but it's also good for you to also know it just in case, because you will be working alongside developers and every other thing. I mean, now that I'm already a developer, I'm already knowing all this, so I will know how to improve my production better and every other thing. Then lastly, your port. What are you now mapping it to? And now let me now explain this port aspect for you. Now we talked about the backend Dockerfile. The backend Dockerfile. Where is it now? The backend Dockerfile. We are exposing it to 8080. That is default for Java Backend. The default port for Java Backend. Now we are now mapping what? The backend. That is the backend port. 8080 to our container port. And now we are calling it 8080. I have now explicitly explained what this port is. We are now mapping our localhost port 8080. We are mapping it to our container port, because remember, we are containerizing this Docker with this application, not this Docker. We are containerizing this application, so we are mapping it from, we expose it to 8080. We are now mapping it to our container 8080, so that this time around, after the container is running in our Docker desktop, this person now, or every user now, can now be able to access it in localhost 8080, because this time around, it's not just your app that is running, it's your container that is running, and this container has your app inside, right? So it's mapping your localhost 8080 to your container 8080. That is what all this one is about. Then for your front end, remember, what is your back end is in your front end also, right? So I think I don't need to explain further as to what is in front end, but you know that yes, first is your image. Remember, you create a repository of your image and every other thing, your username, your repository name, and then your tag, which is latest. Then volume, what I said you are going to link your front end. Remember, the front end, there's a folder front end here. Look at this, the folder front end. You are going to link your front end. This colon means linking or connection. You are linking your front end folder to what? This Nginx HTML. You are linking it, right? You are linking it. Remember, we talked about user share Nginx HTML in our Dockerfile for front end. That is where Nginx web server goes to check your files. So this time around, you are now linking your front end files to that volume, so that whenever you make changes in your front end code, let's say for example you saw edit, now you want it to be edited or edition. Now you now change it edition. So this volume will now link whatsoever is in your front end file here and link it to your what? Nginx in your Alpine Linux machine, right? It's going to link it to that place. But remember, I told you that without this develop watching, it's not going to automatically do it live while on production. That is, while it is running live, it's not going to do it for you automatically until the only way it can do it for you is to now stop this thing and then rerun it again, and which takes time. So why not just put the develop watch action to actually update while on production, rather than stopping your Docker desktop again and then rerunning it again and building it again, and then now see the new actions there. You see it now. So that is why this develop watch action is vital for this volume aspect, because automatically, of course, it's going to change, but it will not change while it is running until you stop your build and rebuild again. That's when it will not change. So for this develop, remember now, we are not going to rebuild action, we are going to rebuild here. You see it now. Then remember your port. In your Dockerfile for frontend, we expose it to port 8080. Now this time around, we are not saying that, okay, since we have the localhost 8080, we are now linking it to our container. This is our container port 5173. So we are now exposing our localhost port 8080 to our container port 5173. That whosoever has localhost 5173 can be able to access the front end of this website. Then lastly, remember that for front end to work, we will need our back end, right? So this depends on, what does this depends on talks about? He's saying that for my front end to work, let me first wait for my back end to run first before I now run. So first, this depend on it now telling us that back end, you go first, work first. Then after you work, I will now work, because I am dependent on you. whatsoever I want to do, I will need you to actually do it. Same thing for backend. Assuming there's a database, the backend will also depend on the database. You know, database first run, oh, then I'll wait for you. After you have run finish, then I'll now run. Then after me run finish, the front end too will depend on me. The front end will now run. So that's what this depends on. Talk about. I've already break it down for you in simpler language. So that's what this docker-compose.yml file is. It's a product manager that manages multiple services for you. It builds it, it runs it for you. Alright, so that is what it is. Then once you are now done, all you now need to do, once you've written all this stuff, the next thing for you to do is to now do your docker compose up. Then that build. Remember, it's build that we are building. We are building front end. We are building back end. Where is it now? Building back end. So we now be build. But if you run this thing, guys, it's not going to run. Let's do it. Now, unable to get image. The back end. You see that why you show back end first? Because the front end is dependent on the back end. It wants the back end to run first before the front end. So it unable to get image. Why is it unable to get image? Because your Docker desktop is not on. So now first you are now going to what? Run your Docker desktop. This is your Docker desktop. You have to first run it first. Right? So I want to run my Docker desktop now, and then I'll now rewrite this docker compose or build. Alright, now my Docker desktop has been opened now. So the next thing, I'll now go back there and run it again. Docker compose up, then tag build, and then run. See now, you see that it's now running. So without your Docker desktop, it's not going to run. So now it has been built. They said, what did they say? Now, first it was backend that built. Look at it, because in your docker-compose.yml file, it was backend that in your front end services you wrote depends on backend. So first backend will build before your front end. Assuming there's a database, it's database that is the first thing that we build before backend, then before front end. So backend has been built. Now the next one is now front end. So now front end has been built. So now the next thing we said that we did our develop watch. We enabled our watch and this thing that whenever I change something from the front end, automatically it affects my container, right? So the next thing for you see under here, you wrote W means enable watch. So I'll now enable my watch. Now they said watch enabled. So whatsoever code I change here is going to affect here. But before any other, that one is at advanced level. Before that, let's look at whether this thing is running. Right? Okay, now look at the image that's built the image. GitHub web front end latest. GitHub Java front end latest. Yeah, built it. Now let's go back to our container to see if it's running. Now okay, it's running. Look at it. Anytime you see this stuff is running, this one is to stop, but I don't want to stop. Now let's click inside to see. Now front end is running, back end is running. Right? Front end is running, back end is running. So all what you are now going to do, since you have seen that they are now running, or you now go to your web browser to test your app. So now I go to my web browser now and then open this thing, localhost colon. Remember, it's front end. That is your web port. So you're accessing your front end, and then from your front end you interact with your back end. So you now for your front end, what is your container listing? 5173. Then you now click it. See, it's showing now, right? Student dashboard and every other thing. No name, student. Then now to know if your front end is interacting with your back end, because back end, this is where REST API works. Don't worry, these ones are actually developed for software developers, software engineers, and whatsoever. Then if for you to test that, you now click add student. I want to add student too. Now it's already looking at that. Now I'm adding student. Then once I click save, which means that my front end and my back end are interacting, right? See, now it's saved. I can now decide to edit, I can decide to delete, I can decide to, the edit is the updating, I can decide to delete, I can decide to create, which is the add student. You see it now. So which means that Locally, because localhost, locally our front end is interacting with our backend, which means that, oh, we are production ready. It's now time for us to host it, or push it to live production, whereby people can now start using it. This is where your deployment comes in on your cloud, on the cloud, because some people now they deploy all this kind of app in Vercel, Netlify. I'm sure some of us know of this, Vercel, Netlify, and so that is it. Everything is working perfectly. Now it's now time for us to push the two images, our Java Backend and web front end, to our Docker hub, and then pull it to our virtual machine, and then run your docker-compose.yml file to host it globally. Yes, that is the right word I want to use, to host it globally for everybody to use, right? So let's do that now. So I think I'll be stopping all this stuff. Or no, if you can either stop it in your Docker desktop here that is using this button. You will stop your container, or you will come to your now this place. You cannot be able to write anything here, because now watch enable, all these ones are here. So instead you are going to create a new git bar, yeah, and then write docker compose down. Now look at it. Now he has already automatically stopped all container. Now let's check whether it really stopped. See, if I check my container now, nothing is running again. You see now, nothing is running again. So that's how it is, right? Rather than using the GUI, you use your terminal, right? So, but you need to know commands to know how to use your terminal. So I've explained Docker for front end, Dockerfile for front end, Dockerfile for back end, and the docker-compose.yml file that helps you to build those two containers locally for you. Now, once you are done with all these stuffs, right? You are done with all these stuffs and all. The next thing for you is to push it to GitHub, right? But before we push it to GitHub, let me talk about the workflow. Right? I will talk about the workflow before we start pushing all these things to GitHub. Now, what does GitHub workflow? It's more like a robot. Yeah, it's more like a robot. It's more like automation, AI automation, right? But AI is not inside here. It's just like automation, automating a robot that helps you build your Docker files. Your container, it helps you to build your container, push it to your Docker repository, then also deploy it for you, or will I say pull it to your cloud virtual machine and deploy it for you there. That's what the GitHub Workflow docker.yml file helps you to do. It's more like an automation file, or more like a robot that helps you to do everything for you, rather than going to this thing manually. After you have pushed it to push everything to, let's say for example, I don't have my docker-compose.yml docker publish.yml file, that is my GitHub Actions. I don't have it in my this thing. All I need to do, I'll first build it to my Docker repository, build it, then push it to my Docker repository. Then after I push it to my Docker repository, I will now go I will now log into my Azure portal and SSH to my VM, and then write docker-compose.yml file, and then do docker compose up and build it. You see now all those Docker pull, right? You first pull your images from your Docker hub, and then you now come and build it. You don't see all this stress. The stress of doing all those things manually. GitHub Action can help you to do everything automatically without you lifting a finger. All you need to do is to push it to GitHub. That is the only thing you need to do. Push it to GitHub, and then the flow action starts to deploy, right? So let me explain what is in this flow before I now push it to GitHub for it to now run all these things for me. So we'll now see everything working. But apart from that, since we have stopped our local host, you see that I remove all these things. If you check your browser now, it's still showing. If I refresh now, you see that it will not show again. See, because I've already stopped it. That is one thing about this thing. If your system off, let's say for example, your system off, and then you gave the person this link, this localhost colon 5173, you cannot be able to, that person will not be able to access it because your system off is running on your Docker engine, on your Docker, that is on your local machine, on your Windows and everything. That is where it's running on your Linux machine here. But now you don't want that, even though your laptop off, you don't want that, okay, people will not still be able to access it. So why not just deploy it on your cloud? That is where cloud comes in. That is why you need to be a cloud engineer, because you don't need your laptop to be on every time for people to access that website or that application, right? So you deploy it on cloud. That is why cloud is important. That is the advantage, right? So now me explain Docker for you. So now the name of your robot or your automation is CI/CD, continuous integration, continuous deployment pipeline. That is the meaning of it. CI/CD, continuous integration, continuous deployment pipeline. It continuously integrates and deploys through pipeline. Now what does it do? It builds, it's push, it's deploy. That is the name. Don't worry. That is the name of your robot or your automation. Leave that. Now, what are we doing? This one from your number 3 to number 6 is your triggering action. So from your number 3 to number 6 is your trigger action. That after you have done everything here in this your Docker project, like in this your repo that you cloned to your local machine. After you've done everything here, that when you push to which branch? Main branch. Then only when you push to main, you are going to run these jobs. Remember this job. That you see that they are these jobs. This is where all the steps you want to do. Push to Docker or build SSH your VM and every other thing. That is for job. So this job has all the steps you need to do. But before that, it's only when you push to your main branch. Your main branch is your default branch. I told us before that that I created branches for every one of us, right? So we'll do git checkout to know the branches that are available for us. Git checkout. Okay, it's saying your branch is up to date with origin main. Git branch. Let's look at branch to list all the branch. Sorry, I go branch. Okay, it's showing main, but actually there are other branches on the repo branch. How did I write? Is it all now? Yes, look at it. Git branch all, which means that both the one that is remote, that is remote, the one in the repository is going to list everything. So now for now is now on the main. I'm currently on the main. That's what it's saying. This asterisk means I'm currently on the main. But look at my remote branch. My origin in my repository is main. Then my origin is main. My default branch is main. But also, we have the Docker-compose branch. We have the front-end and back-end branch. We have the GitHub CI/CD branch, right? So if you want to check all these things, you know that they are true. So let's go to our GitHub repository to check if it's true. Now look at main branch, right? You are in the main branch. Now click on this. See, you could see that now. What do we have here? Docker Compose, front end and back end, GitHub CI/CD, right? Remember, look at your main branch is your default branch. So which means that yes, all what we saw in our terminal there is true. So I can decide now. For example, I'm now a front end guy. Git check out what is this one, front end, back end. I want to work only on the front end, back end. Remember, then front end, back end space, then main. You are trying to say that create front end and back end branch under main. So main is the head. Look at it now. Main is the head. So all these ones are the babies. They are the subnets. Just like there's a virtual network called VNet, and then it has subnet called web subnet, app subnet, and database subnet. All of them are reporting back towards your main. All of them are stewards, and they will be held accountable by main, right? So that is how it is. So I'm now going to press enter. Okay, error path did not match the file on Git. Okay, let's put git check out. Check out just front end and back end. Now will be overwritten by checkout. Yes. Okay, he wants me to commit my changes first before whatsoever. But that's how you actually do git checkout whatsoever, and then once you git checkout into this the repository, you can now be doing whatsoever you want to do. So that is that with this thing. So on push to main now, which means that now, for example, you did something on your front end and back end, you change some files and every other thing, and then you now push it to your front end and back end. Once you push it to your front end and back end, it's not going to, this your GitHub action not go work. It's not going to run. But when you now merge it to your main branch, that's when it will run. When you now merge it to your main branch, that's when you now run. And how do you merge it to main branch? Let's say, for example, you now git push to origin front end. This is what that is after you have committed all your work in your front end. You now say git push origin. Remember, instead of main, you put front end and back end because you are currently working on the front end and back end branch. So once you now push it to the front end and back end, the next thing you will now check out to the main branch. That you will now come to the main branch. When you now come to the main branch, you will now do your git pull first. When you git pull, right? When you git pull, then the next thing you now put git merge. You now merge, then you now put front end and back end, that you now put the name of the branch you want to merge main with. So once you now merge it finish, once you merge it finish, you see that it's already merging successful. Then the next thing is not going to show. You don't think that it's going to show under your main branch when you go and check your repository. The next thing now for you to do is now to git push origin main. You now git push it. So when you now git push it, now it's not going to show, and then not only going to show your main branch, this trigger action will now work. That is how it is. That is the step. So I'm actually breaking it down for you in steps, right? So that is what this on push branch main talks about, right? So the next thing for us to do is to now write the jobs. What is this automation going to do? What is this robot going to do for me? Right? So now what is going to first build and deploy. It's going to build and deploy. Yes, that is one of the job. And then it's going to run on what? What is it running on? Which means that this GitHub is going to provide a machine for this workflow to run on. Are you understanding now? It's going to provide a machine for this workflow to run on. What is the machine? Ubuntu latest. Yes, it's a Linux machine. So it's going to run on Ubuntu latest, right? So this is which means that everything, all the steps that is here, everything will be running on this what? Machine. All right. Then now, since you've known those places, then the next thing is now the steps. Now that's where they put steps, right? Then name, checkout repository. What does this checkout do? It's going to what? Carry all your files that is in your repo. Remember, it's GitHub that is doing all these things, like all this workflow. It's GitHub. It's going to carry all the files that is in your repo. Since you have pushed it to your repository, it's going to carry all the files, and now it's going to update it in your what? Machine, Ubuntu latest. It's going to update it that, okay, after the repo that we are going to use, it's going to carry it from your current repo, Docker project, carry the Docker project, and now put it in your Ubuntu latest. That is the first thing it's going to do. That is what the checkout repository is going to do. That is the action here. Action checkout at v4 is going to carry your repository and put it in Ubuntu latest for us to see, this is the repo that we are using. Then number 2 is now going to set up Docker build. What is Docker build X? Docker build X is a Docker build tool for building Docker images. That is it. simply the explanation. It's a Docker build tool for building Docker images. Okay, you are going to set up Docker build X because we are going to build Docker images, because in this your repo that we check out in this up here, that we carried all the repo and we put it in Ubuntu latest, which means that Docker files are inside also, right? Yes, Dockerfile for Frontend, Dockerfile for Backend, all the old files that you are seeing here, all of them are inside the Ubuntu latest now. So now we are now going to set up Docker build X, which is a tool to build the Docker files for front end and back end. And let's say there was a database there, it's also going to build the database too, right? So that is what this setup build X is all about. Then the next thing is the step 3. After you have built your Docker whatsoever, right, you are now going to log into your Docker hub, right? Logging into your Docker hub. What are we doing? We are calling the login action. So your GitHub workflow, we call the login action, your Docker login action, right? Let's say rather than you manually going to your Docker hub and then log in, or in your terminal you type Docker login whatsoever and then your Docker login username and then do whatsoever. You see now, this GitHub on Ubuntu latest, on your Linux virtual machine, on Ubuntu machine, is going to log in your Docker hub, just like what we are doing Docker login here. It's going to do it for you. You see now, that is why workflow is actually better. It's going to log in it for you. Now you are not going to what? Provide your username and password. Now why do we use this stuff? Why do we use this stuff? Secrets.dockerhub username, secret.dockerhub token. Like I've said before in our last 2 classes, that these are what? Sensitive data that you don't want to expose to other people out there, because the moment you push this thing to your GitHub, right, is now exposed to the public, except you make the repository private, which is okay. That is when you can now delete this and exactly put your username and your password there. But since the repo is not private, it's public, you are going to keep it in a secret, right, in a secret repository. So which means that it's like a safe for you to use anytime. So nobody can actually tamper with it, right? They cannot tamper with your username or your password, right? So that is how it is. So now, I think I told you how to set up secrets. Okay, let me I've already told you in the last 2 classes, whereby you go to your GitHub, the same repository, right? Then go to settings. You go to settings. Then you come down to what? Secrets and variables. Then when you come down to secrets and variables, you see action, code space, and dependables. But you go to action because it's the actions that we are doing. Then in action, you now see new repository secret. This way you add new repository secrets. Now look at the one that I've already created. My Docker Hub token, my Docker Hub username, my VM host, my SSH key, my VM user. I've created them because these are my sensitive data. I don't want anybody to tamper with it and go and use it to do whatsoever. You understand? So that's why we use that aspect. So that's why these ones are here. That is why these ones are here. Remember your $ now, bash scripting. That is calling what? It's calling the value of this variable. Right? So that is it. Right? So that is for step 3. Then for step 4, is to build and push to back end. Right? Now, we are building and push to back end. Since we have already set up our build X tool, we have set it up already on our Ubuntu latest. Now, and then we have already logged in to our Docker Hub repository. In our Ubuntu latest, still all of them is running on what? Ubuntu latest. So the next one now is to now build and push the backend images. Now we are now going to build on our Ubuntu latest, right? We are now still going to build on our Ubuntu latest. So we are now going to call the action Docker build push action. We are going to call it. Now, since we are calling it now with the context of what? What are we building from? Where are we building it from? That's what we are trying to say now. Where are we building these images from? That's where we say, that's where with context comes in. backend. So with context backend, which means that, oh, this repository that I check out from the beginning and put on Ubuntu latest, this repository also included backend folder. This is the folder here. It included the backend folder. So since I'm building my image, my Docker image, taking it from my backend to build. So after I build, then I tag it with the image latest. That's where the tags is. I tag it with the image latest, and then I push it to the Java Backend repository. I tag it with latest, and I push it to Java Backend repository that I've created. So for it to really push, you have to make your push to be true. If it's false, it's not going to push. That is Boolean logic, right? So then the next thing too, you are going to do it for your front end too. Same thing that you did for your back end, you did it for your front end. You build your front end images by using this action, Docker build push action, and then where are you building it from your front end folder. This is your front end folder that is already on your Ubuntu latest, and then you tag it with latest. You tag it with the latest version, and then you now push it to your Dockerfile web front end repository. Your push should be true before it's push. So all these things we'll be doing, we push automatically to you will even see it in your Ubuntu later. No need to even run because you've already built it, and then you've not tested it with your Docker engine here, and then you've not seen the changes. That now the changes is now wonderful. Though your production on your cloud is live, but you are testing some new features, right, in your local machine on your Docker desktop. Now it's now time for you to now push all your new features. Since all of them are now working, you now push all of them to your live production on your cloud. All you need to do is you just, rather than doing your Docker login here and every other thing, then now pushing all your images to your Docker repository. Just push all your files to your repo on GitHub. Once you push all your files to your repo on GitHub on the main branch, like I said, the trigger is on the main branch. Once you don't push it, the next thing, this GitHub action will start running, and everything that you would have done manually will be automated automatically. So that is why automation is better, man, right? For softwares and every other thing. So that is that for front end and back end building. Then step 6 is to deploy on Azure VM via SSH. Right now, why did we do that? Some people ask, why did we not just in this our GitHub workflow, we'll create a virtual machine. Then after we create a virtual machine, we will now SSH into the virtual machine. Then before we now do whatsoever we want to deploy inside the virtual machine. Right? The reason why we did not do that is because number one, in our what are they calling it now? Word document in the what they say we should do. In our question, where is it now? In our question here, look at it. Docker for Docker project. What they say you should do? They say for the bonus, they say implement a GitHub Actions, a CI/CD pipeline that's what builds the image, push them to Docker Hub. Now look at, we have done the one, build the image and push them to Docker Hub. Then SSH into a Linux VM and deploy the containers, which means that it does not need to create. We have already created it. There is an existing Linux VM. That's why I said now you are already deploying something live already on cloud. So all you need to do is you just SSH into the Linux VM and what? Pull the Docker images and deploy there. So this one now you are SSH. That is the reason why we are not creating in our GitHub workflow. Yes, that is the reason why. So that is the reason why we are SSHing into our Azure. So remember, SSH means secure shell. SSH helps us to remotely have access to a computer from our own computer or from any other computer you want to access. But the computer you want to have access to must have what are they calling it now? A public IP or Azure Bastion. must be integrated on that Linux VM. Remember that we were saying that future enhancement on virtual network should be that we should implement Azure Bastion on it, right? For remote SSH, that is remote secure shell, right? So now we are going to SSH. Now name is to SSH on Azure VM. What is the action? We are calling what? The Apple Boy / SSH action. This is the action that we are going to use to SSH into it. But we cannot SSH into it like that, right? We will need to first what? Login, right? Remember that we'll first do AZ login from my local terminal. AZ login. We'll first do AZ login. Then authentication first. Come and see, this one is the manual stuff now that I'm doing now. It's the manual stuff that I'm doing. So now it's going to retrieve the subscriptions that of my account. Okay, this is the only subscription. Then I'll press enter. Then the next thing, I've already logged in already. I've logged in already. So now the next thing now, I will now come my SSH into my VM. Then I'll have to SSH Juki IQ at then the IP address of my VM 20.0.250.3. Right, so the next thing, it logged in automatically, but normally would have asked for password, right? But because there's something I did actually that made it automatically logged in, because I actually copied my SSH from my virtual, that is my remote machine. This is my laptop. I copied it to that place there. So that is the reason why automatically it's just logging in without asking for password. But on the norms, if you log in your own, you usually see password, so you must write password of your Linux VM there, right? So that is it. So which means that it cannot just SSH in this your GitHub Workflow. It cannot just SSH like that. It cannot just have access to the Azure VM like that. It's going to have, you must use your logins and all. Right, that's where with all these ones comes in. With host, what is your host? Your VM host. What is your VM host? The VM host here is your IP address. So I put my 20.0.250.3 in this my secret in my VM host. Remember my secret there. Then my username, what is my username? Juki Aiku, like what I wrote here. So rather than writing Juki Aiku here, I put it in my secret there so that nobody will know the username. Then my key is my VM SSH key, right? I develop it from my my remote virtual machine here. All you need to do is to cat, or not really cat. All you need to do is to okay, I'm already in my virtual machine here. Let me go back to this place. What are they calling it now? Cat /SSH or let's see the first two /SSH .SSH. Now I've already seeded into it. Now let me list. Now this is what I copied. This one. This is what I copied. Right? In this my VM SSH key. So what did I do now? And I do cat. Now I'm opening ID_RSA. So this stuff, this is my private key. This is a private key. Right? I copied everything here. I copied everything here, and then I went to go and paste it on my GitHub Secrets, right? GitHub Secrets, that's where I'm going to paste it. So that is my key that I used. But normally we also have used password now, right? Yes, then the password is supposed to have work, whereby we put password, right? Then when we put password, so it will be password. That when you created your virtual machine, remember you put admin username, admin password. If you could remember, admin username, admin password. You specify the size of your VM and every other thing. Then admin username, admin password. So password. That's where this you now put your password, the password I used to open that Linux VM. You put it inside that secret. But me now, I go and pass the long journey and use a key, right? So I used key in this place. All right. So that is for that one. Then after you have now SSH successfully, because all of them will be working on this thing. After you have SSH successfully into your VM, then the next thing is to now run this script. Don't worry, I commented this one out. All these ones that you saw, hashtag, I commented them out. This is where it started from. So the next thing now, since I'm now in my Linux VM that I've SSH in this place, I will now change directory to my home directory. This is my home directory. Then after I change my directory to my home directory, remember, I've already created a docker-compose.yml file. That's where I am having my full chest, or I have the full chest to run this stuff, right? That's why I have the full chest to run this sudo docker, because if there's no docker-compose.yml file in my Linux machine, all these commands will not run. These docker-compose commands, they will not run. Let's go to my Linux machine to check. Now this is my Linux machine, right? I want to list it. What is inside my Linux machine? Now look at it. Docker-compose.yml file. You see that my docker-compose.yml file is there. So that's why I can now, with my full chest, run docker-compose up tac detach mode, and I will now run, and then it will run, because this docker-compose will recognize that there is a docker-compose YAML file in that directory. Then let's go ahead and run. Right, that is the reason why I have the full chest to actually run this stuff, the sudo docker. But normally, if you want to actually maybe automate it, all you need to do after you do this you change directory to your home directory. The next thing for you to do is to create a docker-compose.yml file by doing the docker. Let's say not deploy.shu YAML. Let's put YAML here. Then let's change this place to compose.
Hello?
So you
How about the talk?
Then
okay, Alpha best. Where the
then you create. Right. Remember you are creating. Right. Then the next thing is to now make it
okay. No, you not tell me.
So now this chi mode means change mode. Then this plus X means make it executable.
I go call them.
Right. Sometimes you see plus RX, which means make it readable and executable. Right. So now this one is X, make it only executable. Right, or by default, without using this stuff, make it only readable. But when you now make it executable, the plus X means make it executable. So after you've created the docker-compose.yml file, you make it executable. Let's say you now write into the file too. I think what are they calling this thing? The nano. The nano command helps you to write into the docker-compose.yml file. So once you write, then the next thing is it will open this thing, and then you will now have to paste whatsoever you want to paste inside. But all of them,
you want to run away.
all of them are just what are they calling it now? I've created all of them, so no need to actually do all these things. So that's how it is with that stuff. So I've already created my Docker-compose already. .yml file in my Linux VM. So all I need to do is to change my working directory in my GitHub workflow. Then run sudo docker-compose down. Sudo is a command that gives it admin access to run something, right? To run something, to change something when there's sudo, right?
Thank you.
So sudo docker-compose down. What does sudo docker-compose down does after you've changed to your home directory? Any build, anything that has already been built before, that has been running before, stop it and remove it. That's what this one means. right? So it's sudo docker compose down stops and remove whatsoever build that has been existing, that has been running on that Linux machine. Then the next thing for you to do is to now do the sudo docker pull. You are now going to pull both your front end image and your back end image. That's where all this one comes in. Sudo docker pull Juki Ico Java Backend latest, right? You pull those your stuffs. After you pull them, finish, then you now do your sudo docker compose up, then tag D. Tag D means detached mode. What I've already explained this one before. What does detached mode mean? It means that whether the file is there, that is the folders, all these folders that are here, whether it's in that current directory or it is not, run. Yes, that is what it means. Run. And it's going to run. If you remove this detached mode and go and put tag build, what does this tag build mean? It means that there are files in that current directory that we are going to build, right? So if you use these two commands together, it will not work because there's no files there. So rather than using this build file, just use only the detached mode file, which means that you have only the images there to run. So run whether the files is not there, the file of the image is there or not. Run for me because it's only the image I need, right? So that is that with this detached mode, right? So now what I did here was sudo docker compose down, remove orphan. Well, the thing is that I was afraid that after I run, my cloud VM will not be they will now charge me from my cloud VM, all those kind of things. So and I had to put sudo docker compose down and remove of that. I should stop after I run, then you should immediately stop it. But what I was actually trying to do then, at that time I was testing at that first time, was that whether my GitHub workflow will work. So this time around, I want us to run all these things here and then go and check it online, whether it's actually deployed online. Right? So Control S. Now, I want to push all this nonsense. I want to push it to GitHub. So once I push all of them to GitHub, to the main branch, we are going to my GitHub to go and check whether this thing is running. Alright, so let's go and start pushing now. Okay, let me now change my directory to back to my desktop. Right, desktop. Alright, then change my directory to, what is that name again? Okay, changing my directory to this. Yes, this is where we are. Okay, too many commands. Let me go back up there. Then normally this one, the reason why this one is like this, I need to put colons. Is it colons? Quotes, sorry. English is hard these days. So you see now, you need to put code before it works, right? So now I'm now in my Docker project repository. Now I need now to push all these stuffs up there. So git add, remember, is the first thing. Add all. This dot means all, right? Add all. Okay, don't worry about the warnings. They say Docker Compose will be replaced with LF. LF will be replaced by CRLF. It's based on Git's kind of writing or whatsoever. Don't worry, when it is replaced, it's going to still work. Then the next thing is git commit, then minus m. What is your, that is message, minus, I'm going to say minus m. Tag m means tag message. There is tag message. So now what is your message? Git commit message, just short message. Okay, updated version. Let's put updated version, right? And then close your listing. So now you have already created some stuff. So the next thing for us to do, before you git push, ensure you pull first, so that you should not have any conflicts or any errors. So you git pull first, already up to date, which means that you have no issue, man. Continue, man. Right? Then you now git push origin main. Now everything has pushed. Now let's now go to our GitHub repository now and refresh. code. Let's go to code. All right, see, something is running. See, some checks is running. Now, automatically, they say on push to GitHub, the main branch is going to what? Start running. Now, let's check our details. Which means that now it's running. You see now, see, everything is running now. Everything is running. Look at all these ones have marked, which means that all these ones have they are completely successful. I've successfully logged into my GitHub. You see, login successful. I've successfully logged into my Docker hub, right? I've already set up my Docker build X, that is the Docker build 2. Now I'm building and pushing my back-end images to Docker hub. Same thing with my front-end images to Docker hub. So you have to wait for a couple of minutes before it's completely deployed. Oh, now I've already successfully build and push my front-end and back-end images up to my Docker repository. Now I'm deploying on Azure VM. Okay, I've successfully executed command to all hosts. I've already container web front-end starting and back-end. Now look at this place. You show green, good, which means that our deployment is successful. If you show cancel, that is red, and it should draw X red color, it means that it's not deployed. Then you will see some errors in this your further details. This one will help you to show the further details. Now, which means that from the beginning to the end, now it's not a complete job. A complete job. Is now a complete job. So, which means that we are done deploying. So now let's go and check. Let me first check before I. Okay, in my Docker compose, before I push, I put compose up, which means that now it has been deployed from our GitHub workflow. It means that now it's working, right? It's working. So that's what it means. Now let's check whether what we deployed on the cloud is actually working. So now we use HTTP colon. All right, this is it here. Look at it now. This is my VM's public IP, right? And remember my front end. Remember, right? My front end container mapping 5173. So now let's run it. See, which means that our cloud stuff is actually working. Our cloud, this thing that we deployed on our Linux on cloud, is actually working. So let's check whether front end and back end are interacting. Now let's go. Okay, there's something there. Let's go to something. Right, save. Oh, it's saved, which means that our front end and back end is working. Oh, let's edit. Okay, code G, yeah, then 151, yes, I'm from group 1, yes, AWS cloud, then we have edited it. Let's see. Oh, it has changed. AWS group 1 or whatsoever. Then you can decide to declare or look at it. It will ask you, oh, delete all students. This cannot be undone. Once I press OK, everything will vanish here. But I can decide to delete by ID. Then I just want to delete only number 1. Let's say, for example, there's number 2 again. Let's say, let me add another one first. Now, look at it. I can now just delete by ID here. I can just delete only this one. You see now. Or now, now I just delete only one. That's for deleting only one. Let me put it back and then press OK. Okay, now 2. I can decide to clear everything. I don't want anything here. Press OK. Now I'm done. So which means our front end and our back end are successfully communicating on our Linux VM, which we hosted up there. So whatsoever you change, give me, let's say, you don't like these features, you want to change some code, change the code and then push it to GitHub. Automatically again it will run those things and again deploy again. So that is how it is. But I beg make I go back to my terminal, go and shut it down back because it's running actually on my DC. So now let me move out. I'm now on my Linux VM, docker-compose down, right? See, I've already removed it. So now if you go back to your web browser again and load this thing, it's not going to show you again. Yes, so that is everything about that. Thank you.